Okay, so the beautiful hypothesis, using Huxley's words, way back when everybody learned the Bohr-Rutherford model of the atom, grade 9, grade 10. Basically, the Bohr-Rutherford model um, hypothesizes that the electrons are orbiting around the nucleus. Sometimes we call it a solar system model. It's the one, like, if I asked you, if you weren't really paying attention, if I asked you to draw an atom, you would draw like a little dense nucleus. Then you draw these little electrons zipping around the outside, kind of the Jimmy Neutron logo. Sorry, I can't draw very well. But that's how we would picture an atom, especially after grade 9 and grade 10 chemistry. It's a great model. We use it to predict ion charges, whether some of them comes 2 plus or 1 minus. We use it for basic chemistry stuff like ionic bonding. It works really, really well. So it's a model, it's a tool, but it works well in grade 9 and grade 10 science. Here's the ugly fact. This guy named Maxwell, when you're done watching this video, check out this. This is a picture of Maxwell's equation. James Clerk Maxwell came up with these crazy equations. I think I've referred to them before. They were theoretical. The math was complicated for the time, and it connected electricity to magnetism. His theory and other experiments confirmed that if you have an accelerating charge, that accelerating charge is going to give off electromagnetic waves. That's kind of what we talked about way back when at the start of our wave optics unit, when I talked about a charged object wobbling up and down, how it would give off electromagnetic waves. That same concept that we talked about there, that came from Maxwell. Bottom line of Maxwell's equations and these other experiments is, if the accelerating charge gives off electromagnetic waves, that means that the electron that's accelerating is going to lose energy. As electrons lose energy, if they were orbiting, they would like spiral in and collapse. Therefore, Bohr-Rutherford model, it can't be right. Because if it was right, and Maxwell's right, then those orbiting atoms would all collapse. So they can't be orbiting, or they lose energy and they collapse. So they can't be right. And you can't say, okay, no problem, just change our model of the atom. Let's just have our positive nucleus instead of orbiting. Let's just put electrons at different positions, and they're not moving. That quick and easy fix, that wouldn't work because, of course, opposites attract, and electrons would just fall into the nucleus. So we need electrons. They're outside of the positive nucleus. They can't be moving, otherwise they give off energy and collapse. And they can't be standing still, otherwise they just fall in and collapse. That was a problem. We need to remodel the electron, remodel the whole atom, but we need it to be somehow, we need those electrons to be moving, but not moving. They can't stand still or they'll collapse, but they can't be moving or they'll collapse. So there is an answer to this riddle. We actually talked about it in grade 11 physics. We'll come back to it later. I want to give you another instance of why we need quantum first.